Okay, welcome to today's class. Today we're learning about functions, and it's kind of your introduction to functions, even though you've been using functions already a lot. Just a heads up, we don't have Thomas with us today to answer questions in the Q&A, so I apologize for that. He had to had to head out just recently, so yeah, he should be, hopefully will be back with us tomorrow. But what that means for class today is I'll do my best to pay attention to the Q&A, but I want to make sure that we get through all the content of the lesson and that we can kind of stay on course through the lesson so it doesn't feel like the flow is being broken up due to different questions. So I'll make sure to take some time at the end of class after we finish everything to go over all the other questions that I might have to skip over tonight during the lesson. So I apologize about that, but I'll do the best that I can, get those answered. In case anyone is here that for the first time, my name is Dustin Myers, and I am an instructor for Lambda School. Lambda School is a boot camp that teaches people how to code, helps you gain the skills necessary to become a programmer, to get some kind of development job. And it's broken up really well. The curriculum is laid out really, really well. In fact, the reason that I was interested in the first place working with Lambda is because of the people behind the curriculum, the people who are actually writing the curriculum, the things that each student learns as you go through the course. Some of the really brightest, sharpest minds in the programming world. There's people on the team that have come straight from Apple as iOS developers for Apple. There's people who have been involved in very successful startups. There's teachers here that have been heavily recruited by Google and Facebook and all the big names out there. So some of the really, really brightest minds are behind this program, which got me excited about coming in and being a part of this team. So how the class works, it's broken into two sections. It's a 6-month course. The first 3 months you learn web development, which is basically how to build a website, or we call it a web application. And then the second half is computer science. And that is more of the academic side of programming. It's the classes that you would take if you got a degree in computer science, a CS degree. And so it's that first 3 months of web dev gives you some really good practical experience for what you'll actually do in a programming job. And the last 3 months, the CS, the computer science part, gives you the skills that you would learn and gain in a college degree. So it's a really great combination of the two. And yeah, just a fantastic program. I'm a boot camp graduate myself, and I've taught at boot camps for the last few years, and just absolutely love what Lambda School is doing. I think the best part of Lambda School is that the price option that you have to pay for the class after you graduate. So most boot camps are set up where you don't have to, or where you pay up front for the class that you take, and you basically have to pay cash or get funding, upwards of $10,000 to $20,000 to $30,000 before you even start the program. and not everybody who pays that money up front actually gets a job afterwards, so it's kind of a lost investment. With Lambda School, we take on that risk for you. So you don't have to pay for the class up front. Instead, after you graduate and get a job as a developer, then you start paying for the class. So really awesome program, fantastic people that are behind writing the curriculum and what you guys will actually learn. So yeah, that's a little bit why I got excited for Lambda School, and I think everybody should have an opportunity to look at it and see if it's a good fit for you as well. Okay, let's jump into the lesson now. So functions, functions, functions. This is what JavaScript is all about. Let me share my screen. And we'll come over here. Okay, I'm going to keep the Q&A open in case we have, if you have a question, oh, don't need it big. If you have a question that you feel like you might forget, is just really burning on your mind, drop it in the Q&A. If it's outside of what we're learning, if you can try and keep that for after the class, that would be great. But if you feel like you're going to forget it or just want to make sure that it's down in the QA, that's fine. I'll probably try and answer just questions that are pertinent to our discussion or what we're coding. So cool. Let's jump into Replit here. So functions are, oh, I need to go back to, there we go. This is what I want. One second. Okay. Functions are what kind of give JavaScript or most programming languages their value. It's the way that you run things, make things happen. It's what triggers certain lines of code to be actually evaluated and run. So this definition is straight from MDN. It says functions are one of the fundamental building blocks in JavaScript. A function is a JavaScript procedure or a set of statements that performs a task or calculates a value. So this is the part that I want us to focus on, this last part here. A set of statements that performs a task or calculates a value. Well, that's what programming is all about. We are giving instructions. It doesn't matter what language you're using. When you're programming, you're giving instructions to a computer to do something. So what we've done so far, there hasn't been a way for you as a programmer to say, okay, computer, do this at this time, so that this, because I want this outcome. We've basically just been evaluating single lines of code and seeing what it evaluates down to. Now we get a chance to give a lot more specific instruction to the computer to say, when I call this function, I want this to happen. And so yeah, this is really what gives life to everything on the internet today is JavaScript functions. That's kind of the point here, that functions run the world, that without functions, we wouldn't have nearly the interaction on websites, on different apps that we have. Another really good bonus of functions is it helps us stay dry. And if you haven't seen this, this is an acronym that means don't repeat yourself. And what that means is we have files of code that can get very long. And so as programmers, we've tried to find ways that we can reuse code that we write and and be able to make our code more concise and shorter and easier to read and understand. For example, if we look at, this is a project that I've been involved in for a while, and it you can see that this one file has a lot of different code in here. And so if I'm looking at logic, if I'm looking at different lines of code and realizing that I'm writing the same thing over and over and over again, then that's just adding more to that to this file of code and making it longer and longer, and it's going to be harder and harder to read as if I or another developer comes through to try and work on this part of the project. So any time that we as developers see two blocks of code that are doing pretty much the same thing, we can use functions to stay dry, to not repeat ourselves. So we use functions that we can call it at two different times in our code, so we don't have to write that same logic twice. There's some pieces of that project that I was just showing you that probably get called, more than a dozen times when someone is just on our website going through the system. And so we could either write that same functionality, that same logic 12 times, or we can write one function that will do the same thing, perform that same task that we're trying to accomplish, and that way we don't repeat ourselves. So hopefully that makes sense. It'll make a lot more sense as we get further on in the lesson. And then finally, we're going to learn about function scope. I just put it here because this is a kind of a bullet point that we're going to talk about later, but it'll come later down in the lesson down here. So we won't dive much into that right now. All right, so functions, if they're so great, let's learn about it. Functions are pretty simple as far as writing a function. So the syntax of a function is pretty simple. There are actually a few different ways you can write functions. The way that we're going to worry about it today is using the keyword function and giving our function a name. It's the most common way to name functions is using this, which is called camel case, where you have a lowercase letter on the first word. So camel case is used when you're combining two words in code, and you put them back to back. You don't have any space, and you do lowercase on the first word and then uppercase on the second word, kind of like the hump of a camel. You'll see this is definitely the norm in the programming world, is to use camel case when naming functions in JavaScript. This is called snake case, and I don't even think that this is valid JavaScript here to use this. We don't want to keep everything lowercase because it's just hard to read that way. So when we're naming a function and also other variables, we use camel case like that. So function, use the keyword. This is just like saying let or const, the function name, and then we're going to add an opening and closing parentheses, and then we're going to have opening and closing brackets. So that's it. That's the syntax right there. Got keyword, name, parens, likes to have that in brackets. Okay, there, and each part of this has an important role in the function. What we're going to talk about first, we won't really talk about function, basically because it's the most simple thing. It's just a keyword that tells your computer that you're running this code in that this variable name is a function. So we're not naming a string. We're not saying, we're not doing a variable like this. We're doing a variable, or we're doing a function name. So the keyword function just lets the computer know that we're writing a function here. The parens we'll talk about in a minute. Let's talk about the brackets. Inside the brackets, you'll usually see the closing brackets drop down a line like this. And in between here, this is called the body of the function. So let's just copy this over here. I'm going to look at this question real quick. Will a function not work if you don't include the parentheses for arguments, but include only the brackets? No, you need to have parentheses in there. So what you might be referring to is the new syntax in JavaScript or in ES6 instead of kind of the older style JavaScript, where you can just name a param and then do a fat arrow function like that. But this is a unnamed function. It's a function that doesn't, this is called an anonymous function. It doesn't have a name. Right now we're going to be using just named functions. We're going to be learning named functions and not that fat arrow syntax. So really good question, Joseph, thank you. But yeah, this is the way we're learning it, and with this syntax right now, we need to have the name and then the parentheses. Okay, so function name. So let's do a new function, and let's say we'll call this function logger. And right here, this is the body of the function in between the brackets. Okay, and it can be as long. There can be as many lines in here as we want in the body of the function. Right now, we just need our comment line and then this line right here. And what we're going to do is console log hello from the function body. Now, somehow, we have to get this line of code to be evaluated and for our JavaScript engine to run this line of code. Because right now, as we hit run, we're not seeing anything console logged. If we console log something out here, and we hit run, then we see that happening. So this line of code is being evaluated on line 33. This line of code on line 30 is not being evaluated, as we can see from our console here. The reason for that is the JavaScript engine isn't going to do anything, isn't going to run anything inside the body of a function until we invoke or call our function. So what does that mean, invoking or calling? That is to invoke a function. We simply write a line of code or a JavaScript expression that will tell the JavaScript engine, will tell the computer, okay, go ahead at this point now, let's run this function. Let's run all the code that's inside the body of this function. And the way to do that is very simple. You don't need a keyword, you don't need const, you don't need function, anything like that. You just simply type out the name of the function that you want to call, and then invoke it with parentheses, like that. And we've seen this a little bit with things like math.random or let's do math.round and give it a number. So we've seen kind of this syntax happening where you have a function name, which is round down here, and opening and closing parentheses. Notice even here we're not declaring a variable, right? All we're doing is running this function. Same with this right here. So if we want this line of code to be evaluated and to actually log in our console, then we need to invoke our function by calling its name and doing opening and closing parentheses. So now let's see what happened. Hello from outside the function body. Hello from inside, from the function body. Let's say inside, from inside. So there we go. Now we were able to get this to run just by invoking that function. And you'll notice, even though on line 33, even though this is written below line 30, it actually logged first. It logged before line 30. The reason for that is, as the JavaScript engine was working its way down line by line and evaluating and running code line by line, it got to line 28. It said, okay, this is a function. I'm going to store this function in my memory until it's invoked, but I'm not going to run it yet. I'm not going to run the code that's inside yet. So it got to line 28. It stored this function in its memory, skipped down to line 31, 32, hit line 33. It said, okay, this is a function called log that's on the global variable console, and it's being invoked, so I'm going to go ahead and console log this. So this line got evaluated, got down to line 34, line 35. Finally, line 37, it sees logger, and it says, okay, I've got a function called logger in my memory. I'll go ahead and invoke that and run what's inside of it. So it jumps from line 37 up to line 29, and it evaluates these two lines of code. And then this runs, and you see that it gets logged after the outside function logs. So let me read what Darlene is asking. The line that invokes the function, does that actually have to be between the parentheses? Are you talking about on line 37 right here? I'm not sure what you mean by that question, Darlene. So we've got our parentheses after the name. So we write the name of the function that we want to call, and then do opening and closing parentheses. So right now we don't have anything in between our parentheses. Our parentheses are blank right now. But this next section with arguments or parameters, we're actually going to talk about what can, oh, it looks like we have Thomas online with us. Hi, Thomas. You're awesome. So yeah, we're with arguments and parameters in our next section, we're going to talk about what we could possibly put inside the parentheses. Okay, I'm going to, Thomas is on. So, woohoo, you're awesome. I'm going to close the Q&A and let him handle that with you guys. And I will continue on with this lesson. Okay, so awesome. So now we see kind of the power of functions that we said, okay, store this logic for later. And when I tell you to bring that up from memory and go ahead and run that logic. So what is something that we could do inside here? Function logger, of course, is going to log stuff for us. We can, inside a function, you can run any JavaScript expression that you want. So we could do a math expression and say math.round 10.8 and run that. Oh, let's console log that. And it did both, it evaluated both lines of code. It logged this string and it logged this math, the result of this math function. We could even call another function. So let's do function, oops, gotta give it a name, keyword name, parentheses, alert func. And this is just going to alert you invoked me from another function. So down here, we will invoke alert func. So again, you type the name of the function that you have defined up here and just do open and close parentheses. There it is. You invoked me from another function. Notice we didn't invoke this outside down here. We could have invoked that function right down here, just in the main line of our code, right? But instead we invoked it from inside this function. So JavaScript stored both of these functions in its memory, didn't run them, came down, did the console log, came down, invoked logger, and that's how we got alert function invoked there. I always forget that keyword, expression. What else can we do? We can, one thing we can't do, which we'll learn about when we get into scope, is declare variables that are needed outside of the function. So let's take a look at that. Let's actually put this into a new function down here. So we can keep this a little bit cleaner. Actually, we've got a whole section for this in function scope. So we'll get to that in just a minute. So, okay. These are very simple functions that we invoke them, and they just do a couple simple things. Now, let's try, what if we wanted to do something like this? Let's write two functions. Function square numbers and function square numbers 2. Let's spell that out because it's bad form to use numbers when we're naming things, functions, variables, things like that. So, okay, and let's say we're given a task is to square the numbers 35 and 82. So pretty easy to do that. We can go 35. Well, let's use JavaScript for this. Dot square. Can we do oh, maybe it only does square root. Okay, let's just go 35 times 35. And we'll console log this so we can see what the result is. Okay, so we need to square the numbers 35, and then we need to square the number 82. So down here, we're going to square the number 82. Great. So let's go ahead and call these. We've got square numbers and square numbers 2. We'll run that code. Boom, there we go. 1225, 6,724. Okay, so technically we have completed our task. Let's put this above our 2 functions here. We've completed our task. We've got functions that will square both of these numbers. We'll say inside functions, because we could do that just on their own line too. But if you'll notice, these are kind of doing the same thing. It's taking one number and multiplying it by itself. Both of these functions are doing pretty much the same thing. So what if there was a way that we could declare what number we wanted as a variable inside this function, and then multiply it by itself, by the same variable. So we're going to call this dry, or let's call it square numbers dry. Now what we're going to use, so the problem that has come up by writing it this way is we're not staying dry, right? So we can use arguments and parameters to make things dry. So let's move all this down here, because this is really talking about this section down here. So this is not dry. Oops. So we've got our task. We're trying to make things dry. This is not the way to do it. So our dry way is to use parameters and arguments. Before we write out our solution to this task, let's talk about what parameters are and what arguments are. So parameters are used when we're defining or declaring a function. So this is used when declaring or when we're writing a function. And what that means is as we write, when we write our function name, got it written here, square numbers dry, inside our parentheses, we're going to declare a variable that's only available inside this function. We're going to say number to be squared. Don't be afraid to use kind of long names to name your variables. A lot of people would just say num here, which would kind of work because in the function name, we kind of get a good understanding of what this function is going to do. But using kind of being a little bit verbose or using kind of naming things this way is never a bad thing because it just is a little more explicit in what we're trying to accomplish in our code. So remember we talked about last week how the point of programming is to write code for a computer to read and evaluate and perform tasks. So it has to be very precise, and we can't we can't mess up the order of like naming this function. We couldn't put the function keyword after the name. So things have to be done very precisely. As you gain more experience and become more of a senior developer, you start to be able to write code that is precise enough for a computer to read and understand and do what it needs to, but also written in such a way that humans can read it and understand what's happening as well. And that's a really good place to be at because a lot of the code that you'll write will be looked at and worked on by other developers later on after you've written it. And so it's our goal as developers to make their job really easy. When they come into your file and look at your code, we want them to be able to very quickly understand what is happening. We literally could write this like so. And this is totally valid. This works. This is a valid name for a function. This is a valid name for a parameter right inside that for this variable, for this function variable. But it's really hard if someone else were to come look at this function, they would have no idea what it's actually doing, and they'd have to look at the logic and try and follow the logic and reason for themselves what this function is going to do. Whereas if we left it like this, they look at this, the function name and say, okay, this is going to square numbers. This is a function that squares numbers. Oh, look, we've got this variable, this parameter called number to be squared. So we know that this is the number that's going to be squared inside this function. So it's very easy to follow this logic here. Anyways, I digress, but it's a good digression. So this parameter is basically we're declaring a variable in here without using a keyword like const or let. JavaScript knows this is a let situation. JavaScript knows that this is a variable just for this function that could be renamed the value could be something else at a different time. So since we automatically know that as part of a function, we don't have to use those keywords. So now we've got this variable available to us, and it's only accessible inside this function. So inside the function, we're going to do our logic. We're going to say number to be squared times number to be squared. At this point, we have no idea what the outcome is going to be. If we console log this, we have no idea what this is going to equal out to, right? Up here, we knew exactly what the outcome was going to be. The outcome for this function is going to be 35 times 35. The outcome of this function is going to be 82 times 82. The outcome of this function completely depends on what value this parameter holds. And we get to give this parameter value when we invoke the function. So just like we get to choose when a function isn't invoked, like right here, we also get to choose at that time when we're invoking the function what the value of the parameter is going to be. And we do that using arguments. So this is a way to pass data to a function's parameters. And let's do that. So if we invoke square numbers dry with our opening and closing parentheses, let's see what happens right now. Right now we're getting these two console logs up here, but for our third one down here, for square numbers dry, we're getting not a number. And the reason for that is we haven't given number to be squared a value yet. So if we look at number to be squared before we try and log that number being squared, we see that number to be squared is undefined, which, if we remember, means that it's something that's in memory, it's stored in memory, but it doesn't have a value. And it hasn't been given a value by a developer, otherwise it would be null. So this just is basically non-existent at this point. The way we give it a value is by passing an argument to this line of code right here when we invoke it. So we're going to pass this with, remember our task is to square the numbers 35 and 82. So we're going to invoke this once with 35. And we see that we're now, number to be squared now has a value. Well, don't forget that we have to do this twice. 35 and 82. So there we go. Now, the first time that it's invoked, number to be squared has a value of 35. The second time it's invoked on line 89, number to be squared has a value of 82. So when we declare this function, when we write out this function, we name a variable inside the parentheses. This is called a parameter. Parameters are used to declare variables when we're declaring or writing a function. When we invoke a function, we need to pass an argument to give that parameter a value. Otherwise, it becomes undefined if we don't pass a value here. So when you invoke a function, you pass an argument to that function. It can be pretty easy to confuse the two, so just work hard to figure out, remember the difference between arguments and parameters. Parameters are used to define variables when you're defining a function. Arguments are passed to a function by invoking a function. Now let's console log that out and do this one. And there we go. We got the result we wanted, and in about half the amount of code. So we were able to stay dry. We noticed that these two functions were doing the exact same things. They were taking a number and multiplying it by itself. So we used this function and parameters and arguments to take a number, to pass in a number when we invoke it, and square it to itself. So we've got one function, and we're invoking that twice rather than two functions, and still invoking functions twice. So we've cut this down almost in half just by using this parameter here. This doesn't have to be a number. This is just like any variable. This could be any JavaScript valid JavaScript type or expression or anything like that. So yeah, so let's come down here and let's talk about function scope. So up here, when we were talking about parameters, I mentioned a few times that this variable is only available inside this function. I can't come down here later and say console.log number to be squared. It gives me a number to be squared is not defined. What are you talking about is not defined? It's defined right here, very clearly, right in front of us. It is defined. But on this line, it's not defined within the scope that we're trying to recall that variable. The scope that we're trying to recall that variable, this is more of a global scope. Let's see if that, no, that doesn't work. Can I move this down? Oh, we'll just erase it and bring it down here. So number to be squared causes an error because it's not within the scope of this file. We're trying to recall this scope from memory at kind of the base of this file, right? So we would call if, but where it's actually declared and where it's saved to memory is inside the scope of this function. And it won't escape outside of this function. We're not able to access it outside of this function. It's only inside this function scope. So that's what function scope is. Is it in between, in the body or in between these brackets is the only place that you can access parameters or even variables that you declare inside here. This is a function scoped variable. Equals can't find me. So parameters are scoped to a function. Variables that are declared with let or const or var are just in the scope of that function. We don't get to see it out here. Function scope variable is not defined. Let me catch up all of that right here. So we'll say variables that are defined with let, const, or var, or defined as a parameter are only available inside that function. So if we have function scoped this, or we'll say param, and we'll say let some string equal hello there. We want to console.log param, and we want to console.log some string. So this would work. We can console log our parameter and we can console log our string, but later on, neither of those are going to be available to us outside of this function. So that's what function scope is, and it's a very good thing. We don't want a lot of these things to escape outside of these functions. So what about variables that we declare outside of our function? So let's say we've got const, let's do let count equals 0. And let's say we have a function called log count. And we're going to console.log count. Is this going to work if we invoke this right now? Oh, not clog. Ah, typing is hard. Yep, there it is, 0. Let's go up here and go ahead and comment all of this out so we don't have that in our console. Okay, 0, there we go. We're console logging count. So we do have access to global or higher scoped variables. They are accessible inside a function. What could we use this for? Why would that be handy to us? What if we did a for loop for let I equal 0, and if I is less than 10, we'll keep going, and then we'll iterate I. And then every time, let's actually set this to 100. So every time that we iterate, every iteration that we do, we're going to do count plus plus. So we're going to iterate our count as well. And then we're going to invoke this function. So we're going to start at 0 and work our way up to where I equals 9, right? And so we're going to do 10 loops. For every loop or every iteration, we're going to say count, iterate yourself 1 time. So, and then we're going to invoke this our function on each iteration. So we expect that it will iterate count. It will invoke this function, which means this console log will run. And there we go. We started at 101 because we iterated before we ever invoked and console logged our count. It would start, if we did that the other way, if we logged it first and then iterated, we would start at 100. So keep in mind that again, your computer is going to evaluate code top to bottom, and it's really important to keep the order of things correct here. There we go. So right now, with this kind of an example, we're starting to really see the power of JavaScript. We've got a variable declared somewhere up here. So we write a function that's going to do something with that variable. And we're not going to call that until we want it to. So we're going to tell our computer when it gets to run this line of code. What if we wanted to be even more implicit on when we wanted to run this? So let's rename this function, since we're going to change the functionality of it a little bit. we want to rename it so we understand the context of the function. We're going to do log count on evens. So just real quick, I'm going to pause for about 30 seconds. I want you to think about how would you write this code that only when I is even, when I is even, log count plus I. I want you to think about what could we do to only run this function when I is even. So we've given ourselves a condition. What tools have we learned for writing conditional statements? We use an if block, an if statement. So if how do we check if a number is even? The modulus. If I modulus 2 is equal to 0, if there's no remainder, when we take I divided by 2 and we don't get a remainder, that means that I is even. Now the only other thing that we need to do is this part here, log count plus I. So we could just do count equals count plus I. And it will, on every even iteration, it will take count and it will add I to it. Log count is not defined. That's because we changed it. 2, 6, 12, 120. So basically, we're adding 2 to, the first time it runs, I is at 0, count plus 0 equals 100. So it logs 100. The second time that it runs, I should be at 2. Count is 100. 100 plus 2 is 102, so it logs 102. The next time that it runs, count should be at 4, right? Or I should be at 4, excuse me. So count, remember, is 102. 102 plus 4 equals 106. Then the next time that it will evaluate this, I should be at 6. So count right now is at 106. 106 plus 6 is 112. And then when I is 8 is the last time it'll run, count is 112. And 112 plus 8 is 120. So we were more expecting something to be for it to log 100, 102, 104, 106, and 108. Right? This is what we first expected this block of code to do. But we can see now that it's not doing that because of this strange phenomenon of having a global variable holding values for us. When it's global, we tend to run into these kinds of issues that code isn't really going to do what you expect it to do. And I want to talk about that while we're talking about scope, because I want you guys to understand that that global scope isn't necessarily a good thing. It lets us access this variable in a lot of different places, which might be what we want to do, but a lot of times you get these weird side effects of the code not actually doing what you want it to do. So probably a better way to do this is let's declare this inside here, and we're going to call it a const. Oh, we need the equal sign. So we're going to use the function scope to make sure that that this count is that this line of code isn't going to do this weird stuff here. We want it to get more to this kind of a thing. Okay, just 2, 4, 6, 8. But now we can't do this because count is no longer a global in the global scope. It's now inside this function scope, and we don't have access to it here. So we know that we have access to count inside this function. This function doesn't have access to I because it's actually inside the scope of this for loop. Okay, this for loop has its own scope right inside here. So how do we get the two things to work together and to play together? We just learned a way to pass data to a function when we invoke that function. Well, we're invoking that function right here. So we want to pass in I right here. Because with our if statement, we're only going to run this code when I is even. And that's when we want this to happen, right? When I is even. So we know that I, when this gets evaluated, when this function gets invoked, I is no matter what, is always going to be even. So we're okay to use I here. And we're going to pass, so this is an argument that we're passing to log count on evens. So we need to define a parameter or else this wouldn't work. So right now if we run this, we just get a bunch of hundreds. So our parameter is going to be, let's name it to add number to add. So we want to log count plus I. So we've got count here. So let's go ahead and console log count plus I. We know that this is going to be I because that's the argument it's going to be passed in when we invoke it. And we're doing something cool here. We're taking a variable that we've declared up here, and we're passing that variable as our argument. So up here, when we did this, we actually passed an actual value in as the argument. Down here, we're passing in an actual variable, but we've controlled the situation enough that we know that this variable will be an even number. So we're okay to pass it to log count on evens. And voila, 100, 102, 104, 106, 108. So now we're really getting into a very controlled situation, very dry code. We easily could have done something like this. And something like this. Comment that out. Something happened at line 126. Aha. And boom, we kind of get the same result here, right? There, now we get the same exact response. But this isn't very dry. There's better ways that we can do this. Right here. So instead of invoking this function on 5 different lines, we're now invoking the function just on one line. and using our knowledge of JavaScript to give it the correct value every time that that gets invoked right here. Whew, that is a lot on functions. There's just one last thing that we need to learn. And then really just like everything else, it will really just take us getting into our homework and practicing. So return statements. The other really cool part of a function is that we can return a value to the line, back to the line where it was invoked. So we're going to call this func with return. Or actually, let's call it returns full name. So this kind of implies that we are going to put together a full name and return that value to where we invoke this function. So let's give this function 2 parameters. We're going to say first name, and we're going to say last name. And we're going to use this keyword return. Okay, there's 2 different ways we could do this. We could just simply return first name plus an empty string plus last name. So right now we are putting together 3 strings and creating, which will create 1 string of these 3 put together. Don't forget this middle space, otherwise it would just be, it would output something like that, your first name and last name without a space. But when you add that space in there, it adds a space in between the names. So we could do it like this, or you could declare a scoped variable and called name and set that variable to the value of first name and last name being combined with that space in there, and then return that variable. So either way works. To return like that. Okay. So what is this return actually doing? Well, let's invoke this function, returns full name, and we'll say, we'll do a string first name and last name. Okay, so this is an argument that we're passing to this function when we invoke it. And this becomes the value of first name, and this becomes the value of last name when we're invoking it here. So there's a couple reasons we want to use a return. Mostly we're going to do that because we want to give this line of code a value. So if we were to console.log, actually let's create const full name, and we're going to give it a value of this. So we're declaring a variable. Variables need to be given values, right? Otherwise they're undefined. What does this value, what does this JavaScript expression evaluate down to? And that's going to be the value of full name. So whatever this evaluates down to will be stored as the value of full name. Well, this evaluates down to whatever is returned by this function. So I could say return the number 0 and then run it, and we should see it in green. Nope, we don't see it in green. That's okay. Let's that and that. And we'll console.log full name. So right now the value of full name is 0 because it's looking at this function and it's looking at what this function is returning. Well, it's returning 0. If instead we want to return name, then it gives us full name. If we want to, whatever we're returning here is what the value of full name is going to be set to. So let's just look at it, make sure that this way does it as well. So we're going to return this expression. We get the same result there. So the return statement is very important and very valuable because we can now set variables according to logic that's run inside a function. Awesome. Yay for variables. Okay, cool. The sun came out and is shining on my eyes now, on my face. So there we go. There's functions for you. If you need to take off, that's just fine. I'm going to run through the chat just real quick like we've been doing this week, or like we did last week, and just see if there's anything else that I can help out with. So again, this is kind of a fire hose to the face, so I encourage you to really rewatch the lessons, make sure you're going through your homework and understanding. I've seen Slack has blown up a lot more the last couple days. Our Web June 25 channel in particular is where a lot of people have been getting on and asking questions, and we've gotten a lot of good threads going on, talking about what we're learning. So that's fantastic. This is exactly what we want you guys to do. We're here available to answer questions, to help you out. We want you to be successful in this mini boot camp and in when you join in Lambda School. And so use Slack. Please ask us questions. If you feel like you're getting frustrated and not understanding things and not getting concepts, just reach out to us and we're happy to help however we can. We definitely understand that this is a lot of material to be covering. So, okay, run through, see if there's anything. This is something, Joseph, please reach out to us on Slack and we can help you out with that. Yes, it is a fire hose to the brain. Yeah, snake case would be used with an underscore, and I think kebab case is what I was referring to when I wrote that. Define the return statement in a sentence, please. How would we do that? Return statement, definition. That is a really good question. I'm going to look this one up to see what MDN says about return statement. Okay, the return statement ends function execution and specifies a value to be returned to the function caller. Perfect. That is a really good point to bring up as well, that a return function ends function execution. So I could come down here and say console log can't find me. And this code will never ever be evaluated, because once you say return, the JavaScript engine stops evaluating code inside this function and goes back to this line here. So if we hit run, you see Tony Stark, but you don't see this line of code. Because the return statement ends function execution. Okay, awesome. Oh, thank you. It was not, you guys got to see my face as I typed all that out. Yay. Let me share my screen again and show you what I did. Okay, return statement ends function execution and specifies a value to be returned to the function caller. The function caller is just right here, is where you call the function. So it's going to return a value to the function caller, which is why full name gets the value of name. But it also ends function execution. So down here, if we console log this string can't find me and run our code, it never gets evaluated because the return ended. The return ends the function execution, and anything that happens beyond our return statement doesn't even get touched by the JavaScript engine, never gets looked at. It is untouchable, unreadable code. Not unreadable, just untouchable. We'll do that down there in case we want to play with this. Return. Okay. Awesome. So it looks like we're down to all of those questions. So, okay. Again, please reach out if you have any questions, and we're more than happy to help. And tomorrow we'll be covering more about functions. Have a great night.